Alright, once again, welcome to the part 2 of the cantilever slab detailing. Alright, on the part 1, we look at how we can detail the slab and how we can answer the question of having a return on a cantilever slab, right? So we look at how we can erect our mat on both directions, because we are looking at it that from the very basic point that our mat should be laid in double directions, which means it's a two-way slab, okay, irrespective of how the slab is being detailed, okay. So that was what we've done in the part 1. If you've not watched that, please do well to watch that video, then we can come back on part 2. And if you find it interesting, please, I want you to give us a thumb up, we're going to give us a like, I want you to subscribe. And if there's anything you want us to know in your review, or a particular thought you have in mind, or a particular topic you want us to copy as regarding this video, please feel free to contact us and feel free to let us know. We'll be very, very happy and more than happy to make that review and that video. My name is STADAS, and I'm your instructor. So right now, let's start. So what we'll do, we'll just start from adding our top reinforcement, because if you look at what we have here, we just did the top and the bottom reinforcement. So we're going to add a top reinforcement. Reason being that when we have a particular a span in this direction, let's say we are having this span, okay, we'll say we are having span of this nature, will agree with me that we're having a lot of moment acting upon this whole area. So all this top rebar will be exerting some moment. All the top rebar, they'll be exerting some moment. This will be at the external, and this will be the internal on both directions, because the slab of this point will be distributing down to this other beam, and the slab along this joint will be distributing down to this beam, and as the case may be. Let's take a simple view of how the load is going to be distributed. Now let's take a look at this simple example. Let's say we'll have this to be our slab panel, okay? Let's say this is our column. We have 4 columns at the 4 edges of this particular slab, and let's say these are the beam, okay? Because in this scenario we are looking at a solid slab, not a raft, not a waffle slab or rib or a flat slab, okay? So we're looking at a simple solid slab, a type of slab by which a beam is independent on is independently supported by the columns, by which the columns, the slab is resting on the beam, okay? We are having the slab resting on the beam, so the load at this point is going to be transferred down to this particular area, by which the load after the load from the slab is going to be distributed down to the beams, okay? Then from the beam, now be what? They're going to shear down to this area, which means this particular load now, in this simple scenario now, if you look at this simple slab, what we'll have is what? We're going to see this load. So this load at this area of this slab is going to be distributed into 4 parts. So the 4 parts, in the sense that this is going to distribute down to this beam, and this particular proportion is going to this particular beam, and here will be going down to this beam. So as this particular area of the slab, you can see that the slab load is going to share itself into 4, and it's going to share to this area. But in a situation whereby you have a cantilever, then it's going to share back to the particular beam that is independently supporting the slab, okay? So having this on note is that the beam is going to be the load is going to be distributed down to the beam. Then this load too on the particular beam, part of the load is going to distribute down to this column, and part will distribute down to this column. Same to this beam, the load from the slab rests on this beam, then from the beam down to this column, and from this other column down to this area, because we'll be having divisions, okay? After the load is being generated, distributed from the slab down to the beam, it's now going to move back to the column, and from the column down to the foundation. So if we have something like this in a numerous order, suppose we have something like this, suppose we have a slab panel like this, you can see how the load is going to be distributed, okay? You can see that this particular load is going to be distributed down to this beam, so is this slab down to this beam, down to this beam. And you can see the total numbers of panel we have. We have panel 1, panel 2, panel 3, panel 4, panel 5, and panel 6. So in all of this panel, you can see that this load is still going to divide into 4 parts, right? So this is going to go down to this beam. So panel 2 down to this beam, and this other will distribute down to this other beam. Whereas this will go down to the beam, and this will go back to the beam. And all the external is going to go sideways. But if you look at this particular beams, you can see that this is distributing down to this beam, and so is this panel distributing down to this beam. So the slab load from this panel, let's say 1, 2, 3, 4. So slab load at panel 4 will be distributing down to this beam, and slab load at panel 5 will also be distributing into this beam. From panel 1, this load of this slab will be distributing to this beam, and from the panel 2 to be distributing down to this beam. So you can see that's why you see in most cases you have the beam at the middle of the slab. The inner beams are always what having a higher reinforcement compared to the external beam. These are some of the secret, all right? That's some of the causes, right? Because you can see the load is distributing only at once or at one part, but you can see over this beam is having load from this part and this part, this slab down to this slab, this slab down to this slab. The same thing to this one. You can see the load coming this way and coming from this direction. Whereas for this beam, we're having a load distributed only on one direction and one direction. There's nothing happening here because of the edge, right? So that's why I say the internal beams are most likely to be higher. They are always critical more than the perimeter beam. So let's go back to our example, right? So after taking note of that, so what you need to do is what you have to introduce a top bar along the span. Okay, we're going to have a top bar along this return. Okay, all these supporting beams. Okay, because of the moment. All right, not necessarily because of the load that we just discussed in the previous example, but because of the load. When we have this particular, when we have this support, anywhere we're having a support, we'll be having a lifting moment along that joint, and when we have the when we have the middle of the span, the middle span will be having a downward movement. Okay, in that sense, that will tell us that when we have this support, we'll be having a tension along that zone. Then at this mid span, the bottom level will be what? At tension, at in tension. So what we need to do right now to ease those tension, we have to introduce to introduce a support, to introduce a rebar at the top of our support. Okay, the top part of our support, which is these beams. So where we have this beam, we'll be creating a top bar along those joints. So what do? So we just go back to our rebar, because you see the layer we first created, you can see the layer is bearing what? Is bearing rebar. Okay, so what we need to do, we just click here. Sorry, let's escape. Sorry, I will not take this. So just click on this. We'll go back to our layer to get our top rebar label. So we can get any of the top. Either want to use the top reinforcement or you want to use the top line, depending on the layer you create, alright? So if you get this AutoCAD template, that's most really why you need to get this AutoCAD template, because you don't need to create more labels, you don't need to create anything. All you need, all the tools you need, all the layer you need to work with, they're all here, alright? So if you need this, so let's click on this. So if you need this particular template, there's a link in our description that you can just go click on the links. If the link is not activating, you can copy the links, put it in your local browser, then it's going to take you down to the store. All right, so let's begin. That's how you get this template. There's a store and there's some apps and there's some other files located in there that's going to be beneficial. So let's continue with what we're doing. So right now we're going to create we're going to create a top bar. So in creating this top bar, the principle governs that the top bar, because you creating a top bar, the question you ask yourself is what will be the length of the top bar. So we're looking at the length of the top bar to be what? At this junction now. So we're looking at having either you do this span divided by 4, or in a simple note, you can say 25% of the span. So if I have the span now to be what? Let's say this span is what? Let's say this span is 2 meter 60. So 2 meter 60. What we need to do is just to get 25% of. Sorry, I'm trying to grade the calculator. All right. So we're going to get 2 meter. We're going to create 25% of this. So in that scenario, we'll say 2601, all right, divided by 4. That's the first scenario. You can see we'll have what? 650. Okay, 650.25. So in the same vein, if I do the same calculation, if I multiply this by 25%, I'm still having the same result. And I said what? It should not be should not be less than 600. No matter what you do, let's say you have a shorter span, but what you're extending into the slab should not be should not be less than 600. Okay, that is a thumb rule that you just need to work with. But in a situation where we have a measurement that is higher than, when you have a measurement that is higher than 600, you just have to use it. So in this scenario, we're going to create, we're going to create that. Let me take this off and let's close the calculator. So what we need to do here, we're going to create 600 and we're going to generalize it. So in this, since we know that 600 for this span, I know that this is the most kind of smallest span in this direction. Okay, aside this, because this is small, we're going to cross our reinforcement over here So we'll just see how we do it. So what we need to do, because of this span, we just have to go 1 meter this way and we'll go 650. So we're going to pick a line. So pick a line, we'll click over here, we'll extend it, make sure our auto is on, so it will be what? Straight. So what we need to do, just type 650 at that point, and there we go, 650. So you come over here, you can see it hasn't crossed this other side of the beam, so you have to take it over the side of the beam. Then you're going to now take in this direction, these two span are not equal, all right? But since I have my minimum to be 600 and I look at this span, so I can just decide to use maybe 800 as the case may be. Let's just say 800. But in a scenario, you can still check the span to be sure of what you're doing. So we can go by our dimension. We'll click on these two beams. Let's check what we have in the span, so you can see what we have here. And we'll go with our calculator once again. Let's cross check what we've done there. We'll have 3199 times 25% times 25% of it. 25% equals to, you can see what we have is approximately 800. All right, this is 799. This is approximately 800. That's why I just use 800 to do. And if you check what we have here, you can see the dimension of what we have here. We have what? We have 800. So we are still on point. Okay, so this is the same. So I can copy this for this other beam. This side now is going to be what? 800. So I'm going to create another line since we have the same span. So here will be what? 800. So let me place it here. The placement is not the problem. You just need to know what you are doing and stick to the tomb rule, to the principle. All right. So the same thing, you can check over here. We have a very short span here. If I calculate this span, you can see that this span is very short. If we check the percentage, we check 4. If we divide this into 4, which is 25% of this span, you can see that what we'll be having here will be about 250. So 250 is very small. Mind you, I said it should not be less than 60. Okay, so I need to cross it down to this part, to the area where we have a wider span. Okay, to the section where we have a wider span. So we still need to check this span and check what we have in this span from this beam to beam. So we still have what? We have 300 to, you can see here we have 3199 and here we have 3599. So if you check the proportion, I can come here and decide to use 900 over here instead of linking that. So to still cross check, to still confirm, you can still go by what? Clicking on calculator. If you bring your calculator, we can still do what? 3599. If we multiply it by 25%, what do we have? We have 8900. Okay, so you can just check a relative figure. You can try to even use 1 meter instead of 900. You can try to use 1 meter as the case may be. You are still on track. In as much as you know what you're doing, you're still there. Okay, let's take off all this dimension. You can see we've done this dimension. So you can see this span will be running along this beam, from this beam down to this beam. That's where it will be running, and the same thing along this vein. I want to run this span down to this whole area. Irrespective of this, I know that this particular perimeter here, there's no span, but I'll still run it, okay, to be safe, to make sure that everything is evenly distributed along that zone. That's the reason for it. Okay, so that's why we need to keep that simple. And you can see along this span also, we've already have a top bar that's going to cross it because of what we have along the span. This is going to serve, the return here is going to serve as what? The top bar. Mind you, any return, we're going to take it as a top bar. So what we need to do here, have to copy this, or we need to do, for me to separate the top bar and the bottom bar so that we don't get confused. What we need to do, let's go to layer and let's change it to dash line. Okay, change it to dash line. It's not activated. Let's go to the line type scale to check the line type scale. Let's make it about 20 and let's see what we got. I think the scale is a bit high along that area. Okay, so that's it. You can see. So we can now copy this line type scale and copy match property so that we're going to have this for all our top rebar. Okay, mind you, all the return are top reinforcements, but they are return at the edge. Okay, for it to return, this will be the bottom reinforcement, and it's going to move down and it's going to return up. Right, it's going to go into the beam and return. Same goes to all the returns. All right, so not necessarily placing the top bar at the return. This can be the bottom So you just have to click only here to make them top bar. So it will be indicated that they are all top members. Okay, they're all top members. So we know the difference between the top members and the bottom members. Okay, that's why I'm just trying to create this just for awareness and easy recognition. Okay, for you to know that okay, this is where we have a top bar and all that. So let me shift this down. I just want to get a very good placement so that um, place it somewhere here. I don't want this to be colliding with this, or I still need to shift this so that it to be separate. I just want them to be unique, right? Just need to do some extra work to make sure that your job is okay, right? To be a bit, right? Because I don't want any collision. I don't want each of them to be overlapping, showing, because it will look dirty, right? So that's why everything is this way. Okay, so you can see what we have now. You can see all the top bar, all the one with the dash, with the breaking line, the breaking dash line at the top reinforcement. Then the continual line are what? All the continual line are the bottom reinforcement. Okay, reminding this, this span, we have this span to be very short. So since we have a shorter span over here, we just have to keep it simple. We have to keep this span very, very simple. All right, so this is going to play top and bottom reinforcement. If you like, you can do a double rebar. A double rebar in this sense, double rebar in this sense. So we're going to have a top and a bottom rebar along that. So this will be the top and this will be the bottom. Okay, taking the same dimension because the span is very short. So you can see because it's just going to run here. We're having a distributed mat, so that is evenly going to take care of that. So now, if you look at this mat here, if you look at it, very, very critical. Now we have the bottom mat along this line. We have the bottom mat to be this, and we have the bottom mat to be this. Okay, so it will be still wise when you have the top mat, when you return, you are going to have another mat that is going to be distributed on this direction. Because when you are return, it is understandable. It is basically telling us that okay, this one that I've returned will be my main top rebar. Okay, my main top rebar. Now in your top rebar and your bottom rebar, we're going to have what we call the main and the distribution. So there's a main and a distribution to both the bottom rebar and both the top rebar. Okay, so you can look at here now in the bottom rebar. This is my main reinforcement and this is my distribution. Okay, so here now I'm going to have this to be my main and I'm going to cross a distribution. Okay, I'm going to cross a distribution. So before we do that, let's finish on the top because we'll finish on the vertical one. Let's get the top along this whole segment. Okay, let's get the same top along this whole segment. So I'm going to click here and I'm going to do the same measurement. Let's just take, because of how lengthy this span is, let's take 900 for the sake of time. Okay, so click down to this part and let's take the same. This span, again, this span will be shorter, so let's go with 800 along here. So 800 will be for this span and 900 will be for this span. We can go back to check to know what we have, if it's suitable or not, if it's what we're going to increase. Now this is 560, so let's increase here to be 1 meter, please. So let's distribute it down to 1 meter. Okay, so you can do your percentage to know the differences, so you know what we are doing here and what you should get a proper understanding of what we are trying to do. So this is by the way. So simply I can just copy this reinforcement. I copy on the wrong reference, so you click on it, click on copy, pick a reference point, and I can come here and click on it to be at that point, and so that will be it. So this will be along this rebar. This return will be our top reinforcement because of how short this distance is. It's going to return and also continue the return along this line. Okay, along this edge where we have this the staircase, right? And this other reinforcement is going to continue from here to this span, and so is this other one is going to distribute from this down to this span. Whereas this reinforcement is going to take over from them and it's going to go. So on the cantilever, let's do the same match property. So we'll have the same thing. Okay, this is the cantilever. You can see what we have here is going to, when we have the cantilever from the previous video, We discussed that you're going to have your reinforcement at the bottom and return it back to the beam, and you now send it into the slab. Okay, right? So your return is going to go back to the beam before you now take your percentage, okay, to send it into the slab. So that has taken care of this beam, okay. So the same thing. So what we're going to do now, we're now going to look at how we're going to place a distribution bar, okay, along this line. So distribution bar in the sense that there will be a bar that will be taken care of, that will be running along this mat, okay. You can see that when we return this and we return this particular distribution, this particular rebar is going to be what? Distributed along this particular zone. Okay, along this particular zone. Alright, area. Same thing to this. It's going to be distributed along this particular zone. But this particular zone will be void because of what? Because of this closure. Alright? Because of this closure. So we need to introduce another one. So we need to introduce another one. I can just copy this. Let me move it. I'm going to move it to have a proper lapping. It can be lapping of 60, 60 based on your drawing, okay? 60, 60 based on the drawing. But on site, they can get a straight rebar to run this area, alright? So it can be 60, 60. So you're going to check to make sure that what you have here and what you have here is up to 60, okay? So that's 60. So if we have the same thing over here, if we click on it, this is 45. So we need to still extend here over down to the slab to make it what? 60. So we need to have something here to be minimum 60 because I'm considering Y12 to be this. Don't forget, your lap length is what? 50 times the diameter of your reinforcement. Alright? 50 times the diameter of your reinforcement. So if I do 50 times 12 mm reinforcement, I'm going to be having 60. So you can see what we have here is 68. So that's bad. But on side, you can record that to make sure that it's straight and that is okay. So in this area, I can use this one. I can use this to cater for this, and for the end product. Alright, this can still run through this span, this span, this span, and this span. I don't need to place everything here and have a lot of call out label, everywhere. I just have to keep it simple. So this same guy, I'll be having it here too. I'll be having it over here. And mind you, if you look at this return that we created here, you can see that this beam needs a return. So we don't need to create additional return here. So we can easily drag it down here and we'll now take our 800. Okay. So there will be a lapping length of 60 between this and this new created. So 60, 65. So let's bring it down to about 60. So that will be okay. Alright. So over here too, you can reduce this down to this span to make sure we have 60. So I didn't copy this line. I'm supposed to copy it and now adjust it. So let's see what we got here. So this is how it's meant to be. So this is how it's meant to be. Okay. Don't forget, this is the top reinforcement. So let's put it over here. The top reinforcement for this beam. Okay. Don't get twisted. This particular top reinforcement is distributing all over this panel, just like what we have our return. Okay. This is the main top, and this is the distribution for the top reinforcement. Right? The top reinforcement, the main reinforcement for the top bar, and this is the distribution for the top bar. You can see that when we have the main and the distribution. So when this is running along this axis, this distribution will be crossing it. We'll be having a placement crossing it along that direction, whereby we have this along this area. So just need to have something like a kind of a mat, just like we have the main and the distribution. So the same thing on the top, we have the main and the distribution. Okay, so we're going to have nuclear mat reinforcement along that zone. So that's just by the way. So the same thing over here. So this is going to cater for all of this, and this is going to cater for whatever place that we're going to be distributing this reinforcement to. Okay, whatever we're going to distribute this reinforcement. So that is by the way. Okay. So that ends up. So what we need to do right now is just create out our call out label. When we create out our call out label, then we can now begin to talk about the call out label and the principle involved in calling out the call out label. All right. So the same thing we have here. Let's just go on. Let's just achieve the same dream. So what we need to do here, we'll just come over to start drawing this. Let's try to create. We'll get a particular one here. Let's get this and take this. I just want to do copy and paste so that will save time. No, I don't need to draw it afresh. Okay, from the beginning. So let me copy from here and check a place whereby I don't have enough space so that everything will be clear. So I'm going to check where I'm going to place the line such that everything will be very, very free and okay along that line. All right. So which other place here is free? I think this point is free. Okay. So I'm going to place it here. Then instead I can rather come here and shift this up. Sorry. I can shift this up and shift this other one up. So I can move this particular ribbon. I can move here because it's going to be stopping here where we have where this reinforcement is going to be stopped. That is the same point where it's going to what stop. Okay. Whereas this is going to move down to the reinforcement, telling you that you are going to run along this area. It's not going to run inside the beam. Okay, it is the beam. It's going to run outside the beam, within the beam. So you can also move this to show that between span to span. Okay, so that's how this particular reinforcement is going to run, and it's going to be the same thing over here. All right, it's going to be the same thing over here. It's going to run the same way over here. So let's copy. It's going to run the same thing over here. Going to run the same way here. Same here. Going to have same here. Whereas I'm going to move this in. Okay. We'll do the same thing over here. We're going to move it in. Because of the span is not equal. So one part is going to be what? Longer than the other part. Okay. So I'll create this. So I'm going to create it down to this spot. So we can now move the text. We'll move the text from this point down to this axis. Okay. So it's going to be in the same line with the text. Okay. So we can see what we have here. We have this beam running from this right. So I'm going to move this. The call out arrow is supposed to be at the end of it. Okay. It's supposed to be at the end of it. So at every end, this is where it's going to be, not at the continue. So it's trying to tell us that this particular rebar is going to span from here down to this point. Stop, continue from here down to this spot, stop, continue to this point, down to this other spot, stop, and now continue from here and down to this particular point. And this is the arrow telling you that this is the label. All right, this is the label for that. So that is how we are going to detail this particular one. And same thing we're going to oppose. That's what we're going to be doing in detail. So if you look at this span, we have this particular rebar running across this span already. Okay, running across this span already, irrespective of what we have here, because we'll be doing our lapping. So as simple as that, we just have to highlight what we have already, copy this, copy the text, click on the text rather. Then we're going to, sorry, instead of move, I made mistake there. I click on move. So what we're supposed to do is to copy. So let's copy, click on copy instead of move, click on copy. Then you copy this and down to this point. Okay, down to that point. So when you've done that, you can now move this call out bubble down to here. Okay, telling that this particular top reinforcement is spanning along this beam. Okay, and this bottom is also spanning along this beam. All right, forget about the 4. We'll edit all of this to get the total numbers of the reinforcement along the line. Okay, so the same thing over here. Now we have the same top rebar running here. So what we need to do is just to create similar scenario what we have here. So let's copy from this down to check, because we are trying to look at how we want to put on this particular top reinforcement here. So let's look at where we'll have a very clear space there to place it, so we don't have collapse. So that would be best. That would be the best. Okay, so you can see this other point. So we need to still copy along this area. So copy from here. I will do the same thing over here too. So right now, we're going to trim this back. I'm going to take this back. I'm going to move this backward down. Then that we're going to have this particular rebar. This particular bar is going to cut across from this span. You're going to mat from this span down to this span. Then after the beam, we're going to have a continuation. So still need to what? To copy this, and we'll place it over the beam. Okay? We're going to place it over the beam. Okay? We're going to place that over the beam. So right here, we have the same scenario here. We're going to place this over the beam. So click over here, and we'll have this. Move it down to this span. So from here down to this portion, and here we're going to move this backward too. Okay, we're going to move this backward too, and we're going to still copy to place here. Alright, so just move it close. So you can see we have this whole long area. Okay, we have this guy here. Let's move it close so that for a better understanding, you can see where it is. Now we are trying to use this reinforcement to mat across this whole line. Okay, we're trying to say it's going to run across this line. But mind you, because of this area, because of what we have in this mat, we are going to cancel this whole area. Okay, because this mat is going to continue the whole of this section. So we're going to take this off. Don't forget, this mat is what we're going to run across here, and it's going to still come over here. But along this line, we have this reinforcement here. Okay, so we having this reinforcement over here, so we're going to take it off here. So we're going to be only on this axis. Okay, it's going to be only on this axis. But mind you, we have another one along here too. So along this area, we're going to take this off too, because we have this guy to run, or we can still leave it along that line. Okay, so I'll copy this and we'll place this. All right, so these are pure details. These are pure what you have from your civil 3D. All right, your civil 3D, when you use your draft to get your detail, this is exactly, you have to know the principle. All right, so you watching this video to this point, you have to pay more attention to for you to be able to understand every detail. It's a video. If you don't understand, you can go back and listen to it again and again, and you're going to be what acquainted with this. Once you can do this, then you don't even need the civil 3D or any detailing software. Maybe if you need it, it will just be for the purpose of what? Purpose of you being accountable, or for you to increase your speed limits. Okay, that's just the reason why we need to get it. Okay, if you've gone to this level. So if we look at this other part now, so we're going to have the same thing over here running along the, so we have to leave it over the span. So taking care of that, so we're going to do the same thing along this area. All the top rebar, we're going to take care of the top rebar and do the call out label for all the top rebar along this line. Okay, so all right, now you can see we've done with everything. So what I just need to do now is just get a call out label for it. So we have a call out label for this and a call out label for this other span. So that was what I just did right now. So what we need to do right now is to start to do what? We'll start to get the line. So for you to know the particular span, let's start to do what? You can see now we understand that this particular reinforcement is running along this span down to this guy. So what we need to do, copy this down to this panel. Okay, so what we need to do here, we'll copy, we'll look at the measurement. We have what 2601 over here, 2601. So we have to look at what will be our desired spacing. Okay, we look at what will be the spacing that you want to employ on the slab. Okay, to be safe, I want to be using 200 as the case may be. In your own case, you can be looking at 150 millimeter, you can look at 175 millimeter, you can look at 200, you can look at 250, depending on what you're doing. It can be 100 millimeter based on what you have, but in today's we'll be looking at what 200 millimeters. So when I have this span, I'm going to be doing 200. We're going to be doing 2601 divided by what? Divided by what? 200. Then plus 1 to get my effective span length. Okay. So I'm going to get my calculator. So if I get my calculator, what do we have here for the span, right? So go 2601 divided by what? 200 millimeter. Then you divide it by what? That will be 13. So 13 plus 1 factor, okay? Plus 1, what we'll be having here? Plus 1. So for this span, we'll be having what? We'll be having 14. Because we have 13 plus 1, we'll have that. So we'll now still look at what will be the length of this region that we are going. This is about 1.2 along this axis. Mind you, this is not for the top mat here. Okay, this is not for the top mat. We have to move this bar down to where we have this top mat is going to stop because of this guy that is running along that line. All right. So if we look at 12 divided by 200, if we do 12 divided by 200, that will be 6. 6 plus 1 will be 7. Okay. So here now, 6 plus 1 will be 6 plus 1 will be 7. So if we do this total summation of this, 14 plus 7, that will be 21. Okay, so in this direction, this formula will be what? 21. So you can see all of this now in the initial stage are all 20, 20, 20. All right, so that's to tell you that this is 20 T 12 and of this. So 20 numbers of 12-meter high heat reinforcement, and this is the bar mark, and this is our spacing. Then this will be the direction. Will it be a bottom and will it be a top? Okay, so in this direction it will be a what? A bottom top. A bottom top. A bottom top in the sense that the bottom it will be the one that will be placed on top. So we're going to place the bottom before we have the bottom top, which means we're going to be placing this reinforcement first, this particular reinforcement first, before we now cross this mat. So this reinforcement will be on top of this other reinforcement. This will be under, and this will be laid. After laying this on the ground, they will now lay this on the side. Sorry. After laying this reinforcement, they now lay in this vertical direction, because we are subjecting to be the long direction in this particular detailing. Okay, so if we come over here, so the same thing. After doing that, you are free to delete this dimension here. So come to the next one, you do the same. What will be this length? So you're going to check what will be the length here. We'll check over here. We'll get to this 1 meter 1. 1 meter 1. If you do 1 meter 1 divided by 200, that would be 5. So 5 plus 1, that would be 6. So the same thing over here. So we just need to get our simple division, and that's what we are trying to do here. So if I divide this, 5 plus 1 will be 6. That's how I got it. How do I get? I divide this with 200, right? 200 millimeter, 1001 divided by 200 millimeter. I'll be having 5. 5 plus 1, which is a factor of safety. That 1 is a factor of safety. So you add 1 and we have 6. So the same thing here. Here, if we do this, what we're having here, we'll be having about, this will give us about 19. But let's do it, let's do the calculation so that we'll follow together. Okay, so we'll say 3599 divided by 200 millimeter. That'll be what? 17 plus this. So if I round up this will be 18 plus 1. This is 17. You can see sometimes when you have, this is 17.995. This is almost 18. So we can do plus 1. So we'll have 19. All right. So here we can make here to be what? 19. Or in your own case, you can still say 18. Either be the case, you are still okay. Okay. But let me take it as what? 1. Let me take it to be what? 19. And after this, I'm going to delete this and I'm going to take this out. And you can see the dimension. So if I do the total summation of this, I'll be having what? 25 here. I'll be having 25. Okay. So that's how I'm going to do all of them. That's how I'm going to be doing that. You're going to check the span length divided by the spacing, divided by your spacing. Any span length you get, you divide it by your spacing. So that's how you're going to get the total numbers of reinforcement that's going to run through all the span. Okay, so let's do the same thing here. So we can do the total summation, because you can look at what we have from here down to this portion. From this portion down to this portion, what do we have? We have 21. So if I want to do this particular length, I'm going to know that this is 21 reinforcement that is going to be along this line. So 21 along this line. So we have the same thing here, 21, and here 21. But we're having a difference. Here is a top bar and here is a bottom top. So I'm going to put this, and here is a what? This is a top bottom. This is a top bottom, mean that it's a main reinforcement. Mind you, the bottom is the main reinforcement, right? Bottom is the main reinforcement in this situation. Bottom is the main situation, is the main reinforcement, while the bottom top is the distribution for the bottom. While on the top, we have the top bottom to be the main and the top to be the distribution in this situation. Okay. So if we have the same description here, we've already checked this, and here what do we have here? Yeah, this will still be the what? The top bottom. Okay. So let's include it so that we'll have this. So the only thing that we'll be having now to come back is just to do what? To change the rebar level, to take the rebar level. Okay. So we'll do the same thing to all of them, and we just have to get what we need to get. So here now on the top, area, we are going to look at this span. Okay, we're going to check what do we have along this span. So if we check here, we're going to check there's 1 meter, that is 5. Okay, so we can get 5 and paste it on all of them. If I do 900 divided by 200, I'm going to be having 4 points plus 1. I'm going to be having what? 5. So let's say 5, and let's generalize the 5 from this point. Let's say 5 along here, and this span is not going to be 5 here. We're going to say here will be what? 5 because of the space. So along here now, you can see we're going to move this down to this area. Okay, because this span is going to run along this panel and run along this panel. This will tell you that this particular reinforcement will be running across, will be 5 space along here, 5 along this direction, and this particular area will be 5. Then here now will be more than 5. Okay, because of the span which is covered. Okay, because of the span in which this is covering. Okay, so you can see this collapse over here. I don't want this collapse to be here, so I'm going to shift one of these, or either sideways. So let's shift the vertical one. Let's shift the vertical reinforcement. Let's check if we've copied all selection. Okay, this is remaining. Then we can now move it so that we'll not be having this collide, right? This collision over there. We can move it to one side so it will be free. Okay, and you check if it's obstructing anything over here, so that is safe. All right, your drawing has to be very simple and transparent. So with this now, this is not bad. Okay, this is not bad, but if you have space, you can still shift it so that it will be very, very separate. All right, so that is what basically we're going to be doing. So on this direction, we're going to check what do we have over here from this span down to this span. We'll be having this almost 2 meter. So 2 meter, that is a 2 meter, that will be 11. All right, 2 meter divided, that is, say 2 meter divided, 2000 divided by 2 meter is 2000. So 2000 divided by 200 will give us 10 plus 1 will have 11. That's how we'll get this. So that's how we're going to be doing all of this. Okay, this is how we're going to be doing total summation of this. And we're going to, after adding them individual span, then you're now going to what? Have the summation of all of them on this particular row, and the same thing on the vertical side. So now you can see we've achieved that. So that's the way you're going to add all the span, and you're going to achieve all the individual spacing on all the spans. Well, when we've done that, you just have to add them. So that's what I've just done. And you can see at the end of the day, I have 5, 5, 5 for each of them. Then at this area, we're having 11 to run along the span and 5 either here. So the same thing, we have 5 over the span. So you just have to add in the individual span. Then you're going to do what? To do the summation of all of them. Then when you have, like in this situation where we have this span running to this span, no need me placing a span number like this. Okay, I just have to introduce a span number when I have different span. Like this is going to run from this place down to this stop, and here there will no continuation here. It's going to continue from here 5 and 11. So in that situation, I have to add the span number. But when I have a simple span like this. Sorry, this is the beam. This is the more reason why when you're drafting, you still need to zoom very close to do your final check to see how you place, because it's not supposed to be in a beam. It's supposed to be within the span to span. Okay, this is supposed to be span to span. Okay, so something like this. Okay, so when you have a simple span like this, that there is no continuation, you just have to go back to add direct note. But when you have a continuous span like this, you can do so. But in this scenario, I just have to leave it based on when you're having a confusion in between both lines, you can still do that. But you can see that I still put 21 and 21. So you can choose to do it, you can choose not to do it. But every other span, you can add individual span when you have a continuous span. Okay, because I have more of continuous span, that is why. But you can see here when I have a single span from this point to this point, then what happened, I have to leave it in this color. So let me copy this. Let me see this layer. We have the current color. Maybe we should just leave that. Okay, so this is what happens. So I want, after doing all this, now you can see we are done with our top mat, we're done with our bottom mat, we're done with the slab detailing, and we are done with all the notation, we are done with even the labeling. Okay, so the only thing that is remaining now, if you look at what we have here, we've changed it from 20. Before it was all 20 Y12, 20 T12, 23 200B, right? But now we've put all the directions, because you need to look at where's the direction. Like if you look at this guy, this is the what, the top bottom, telling us that okay, this is going to be laid first, and we're going to have this bottom, this top. You can see this one is the top here. You can see this is the top from here, from the colored line. You can see the top. That is the TT, right? TT means top, and the what? The TB means top bottom. So we're going to put this first before we're going to now cross this all along. So this is going to be returned. After we return this, after we place this bar and we return to get our top mat, we now cross this at the edge. All right, so that's it. So along this span, this will now be serving as what, at the top, bottom for those regions. So we are going to have, and so you can also do to the horizontal direction and the vertical direction. So both directions we're going to be having that. Okay, so that is okay by me. So the next thing we're going to do right now, if you look at what we have 6 numbers of Y12, and the bar number is 23, 20, and the spacing is this and this. So that's for this bar. So the next thing we need to do, we have to look at the dimension. So we have to look at the bar mark. Okay, so from our previous video where I detailed a slab, you can see where I explained a lot of principles regarding what the slab bar mark, a lot of bar marks. So please, you do well to watch that video. I can still throw a light on that in this video. So what we need to do, for you to get a bar mark, there are 4 factors that recognize that. Okay, but 3 basically. We have what we call the shape factor. The shape factor regarding what kind of shape do we have. Look at this, is a straight shape. You can see this is another shape. You can see this is another shape. All right, so I have 3. This is a shape 1, shape 2, shape 3. Okay, in as most of this. All right, so this is a shape factor. Then we have the length, okay, which is the dimension. Okay, what will be the length of it? You can see this guy will have a different length from this guy. If even as we have the same shape, a return shape, you can see we have this shape and this shape are the same, and this shape are all the same shape, but they have different lengths. Okay, so that's another factor. Then we have the size factor. In a situation whereby I can have different sizes of reinforcement, should I have 12 mm reinforcement, should I have 16 mm, 25 mm, 20 mm, and the case may be. So that will be another factor. Then we can look at the number factor. Okay, a number factor comes especially when you're doing a detail your staircase, or when you have irregular shape of the slab. You know, if I'm having something, maybe we'll do a particular video regarding irregular shape of slab, then I can show you exactly where you can use number factor when you're doing when you're considering your what, when you're considering your bar number. So for the sake of this video, what we just need to do, we just focus on the 3, because what we have here is just as simple as the shape, the number, and the shape, the size, and the length of the reinforcement. So that's what we'll be playing at to detail. So if we look at the first one here, you can look at this length. We don't have any other length that is like this. So we're going to call this one 1. We're going to call this maybe 01. Okay, so we'll go to the next one. So the next one is what is the top reinforcement, which is this. Okay, so we're going to call this 02. That's how we're just going to place. We'll just be changing this that is already there. That's why you need to get this AutoCAD template. It's very, very important that you get this Stonebridge template when you're doing your design. All right. So when you've done this, we'll go to the next one, which is 03. 03 is this other length. Okay, this is the size of this length. Although we have this shape to be the same as this shape, but you have this different length. So the different length will come with a different bar number. Okay. So the same thing over here. We have a different. This should be 04. 04. This length is different from this other length. So what we need to do, this 1 2 is different from this size. So go with 05. So when you're doing your bending schedule, this is what you factor in such that it can be traceable on site. Okay. Sorry, this should be 06. We're going to add 06 here. So here now we're having 07, 07, 08, because of the different shape. If you look at this shape, it's quite different, and this shape is also different. So just continue 08, and in all of them, this will be 09, 09. Now we have this shape, although we have this running along this line, but consider this is different from this guy. So we need to go with 10, and we'll go to the next one. The next one will be this length. We have it different, so it will be 11. Okay, this will be what, 11. And what will be the next step? The next step is this reinforcement is a different length. So this will be 0, this will be 12. So go to the next one. This top rebar is a different length along that line. Okay, but before then, there's a particular one here that we did not consider. Okay, there is this guy here that we did not consider. So let's just add space for that particular reinforcement there. That's why you need to do a cross check before you do your rebar marking. Sorry, I click on move. Let's go with copy, because I want to copy this reinforcement. I'm not moving it. Just copy it, copy it down. Okay, I'll delete 19 because it's a single span. It's not a continuous span, so I just have to delete it. So after doing that, okay, I'm now going to move this down. Okay, you can see that this particular slab was not duly, and this particular panel is what, 19. So I'm going to take 19 over here, 19, and 19 here will be what, 12, and here will be what, 13. All right, 13, and the next one will be what, check the length, they are all different. Okay, so here will be what, 14. We're having 14 here, we're having 15 here. Because of this different length, so you have to check the length for detailing. You can see this is different from this. So we're having 15 and we're having 16. So typically, to see what we're having here, we are having a different bar number all through. But in some situation where you have, depending on the shape of the plan, you can have similar top reinforcement running the same span, so we can detail them to be what, to be the same length or having the same bar number. Okay, but for this situation, all the bars are different. There's no other one that are similar because of the length. We have similar shape and we have the same size, which is all to be what, T12, but they are all different shape and different length. So regarding that, that will make us to have different bar number. So you can see now we've gotten all the different shape, and we're getting all the detailing complete stage of the detailing, and you can see we have different numbers over here. We have 21 numbers of 12 mm reinforcements, 9 bar, and the spacing and all of that. So we've come to the end. So this is how you're going to detail your slab. So the next thing you need to do, if need be, you're going to do what? You're going to add the dimension for all of this. So you're going to create a dimension so that they can be able to access the dimensions. Okay, because you leaving it, there's no way they're going to what to know that okay, this is going to be the measurement and this will be going to be the measurement. So on this now on site, somebody can know that okay, from this beam we're going to have this, and so we're going to add the size of the beam, then we'll now know what is going to be into in. Or if you don't want to do that, you can just do a direct measurement for all the span and you cross it. So either which way you want, you can just go with that and you create it, and that will be all for simple recognition. But why I prefer this will show you what will be the ratio that will be entering into this portion and the ratio that will be entering into this portion. So either of this span, they are all good consideration. Anyone you want is you choose preferable is okay. So you can just do your numbering, and do all your detailing. So this is the basic thing and how you can detail your slab to make sure that you detail everything detailed, and everything should be space neatly placed. Okay, you don't have anything colliding with the rest of it. So this is how you can do all of this detail. So you can see here we have 8. So the same thing still goes. Alright, the same thing still goes. So that's how you're going to place all your rebars and how you're going to detail them, especially the return. They have to come with with the dimension, so it will be very easy and traceable on site. So this is basically what you do to your slab. Okay, so the next step will now move on to how you can cut our section. Okay, we'll now move on to how we can cut our section. All right, so I'll be trimming this to be the part 2 of the video. So on the part 3, we're looking at how we can create our section. Okay, so stay tuned, please. Thanks. If you've not subscribed to this video, please, I want you to subscribe and like this video. Feel free to give us your comment, your review on this. If there's anything you wanted to share with us, please, we'll be so happy to have you. Thanks and bye for now.